Hey guys, parallel and perpendicular lines is day 3. Parallel lines are lines that do not intersect. Let's see, lines that do not intersect. And how to check and see if something, how to check if lines are parallel, they must have the same slope, which is our m, and different y-intercept, which is our b. Y'all remember y equals mx plus b, right? Hopefully this is kind of a repeat lesson for you. Parallel lines have the same slope and different y-intercepts, and perpendicular lines, we just have opposite reciprocals, slopes, okay? As a reminder, we're going to be working out of y equals mx plus b for all of this. And m is our slope, b is our y-intercept, right? That number all by itself is the y-intercept, and the number connected to the x is the slope, okay? So really we're mainly focusing on this, and then this one we're just checking to see if they're different. So parallel lines, this number must be the same, and this number must be different, okay? And so if we wanted to write an equation for parallel lines, if we had y equals 1/2 x plus 3. It says write an equation for a line that is parallel to the given line and passes through a point. Well, we're going to use point slope form. Why are we going to use point slope form? Because we have a point and we have our slope. It's parallel to this line and it goes through this point. So we're going to use y minus y1 equals m times x minus x1. And we're just going to plug it in. You remember this is our x1, this is our y1, and this is our m. So plug it in. We have y minus 4 is equal to 1/2 times x minus 1. Okay. And we're going to distribute the 1/2. And we get y minus 4 is equal to 1/2 x. You remember, it doesn't matter if we have decimals out here. It's kind of preferable that we have decimals back there. So 1/2 times -1 is going to give me -0.5. Now we're going to add 4 to both sides, and I'm going to get y is equal to 1/2 x minus or plus 3.5. Okay, 1/2 less than 4. This is going to be parallel. We have the same slope, and our y-intercepts, albeit close, are going to be different. So it's okay. It's still parallel. All right. Now, what about perpendicular lines? Well, let's look. Perpendicular lines are lines that intersect at 90 degrees. Okay? Lines that intersect at 90 degrees. So, and quick thought. Whenever in geometry, the symbol, this is the symbol for parallel. Oops, 1 R, 2 L's. That's how we spell parallel. The symbol for parallel lines are going to be 2 sideways L's, like that, 2 slashes. That means parallel anytime you see it. And the symbol for perpendicular is going to be an upside down capital T. All right. That means perpendicular. That means parallel. So we can actually in geometry write shorthand, say parallel lines, and we can say perpendicular lines. Okay. Or we can say, line P is perpendicular to line Q. Pretty simple, huh? And we can put our symbols over the top of them. So geometry is kind of writing in shorthand. But lines that intersect at 90 degrees are perpendicular. How to check to see if lines are perpendicular is we look at the slope. Remember, we're looking at our m. And we want to make sure that, we want to make sure that they are opposite, meaning one is negative, one is positive. Reciprocals. So flipping that fraction. And you remember all numbers are fractions. For whole numbers, if I had a slope of 3, so like y equals 3x plus 2, if I wanted the reciprocal of that, it's a fraction. It's just 3 over 1. So I'd flip that and say 1/3. An opposite version would be -1/3. Okay? Now, the prompt tells us to write a perpendicular line to y is equal to 1/2 x plus 3, and it needs to go through 2, -6. Well, we're going to use point slope form again because we have a point. That's our x1 and our y1. This is our slope, but we need it perpendicular. So we need to flip it first, and then we need to change the sign. Okay? So flip it first, and 1 over 2 becomes 2 over 1, or 2. It's positive, so I make it negative. So my new m must be a negative 2. Flip it and change the sign. Now we plug it into that equation, y minus y1, which is negative 6. So y minus negative 6 would give us y plus 6, is equal to negative 2, our new m, times x minus 2. Distribute, and I get y plus 6 is equal to negative 2x plus 4. Subtract 6, and I get y is equal to negative 2x minus 2. Do we have opposite reciprocal slopes? Yes. Therefore, they must be parallel, or they must be perpendicular. Okay. This is definitely a repeat lesson. So I hope you remember this stuff. All right. Let's go through the examples. It says on example number 1, it says, what is the slope of all lines parallel to x plus 2y equals negative 4? Number 1 says x plus 2y equals negative 4. We're just going to solve for y on all of these and highlight our slope. Okay, so subtract x on both sides. I get 2y is equal to negative x minus 4. Divide by 2, divide by 2, and divide by 2. You remember we have to divide all the way across. And we get y is equal to negative 1/2, or negative x over 2. You remember those are the same things. Negative x over 2 and negative 1/2 x. Those mean the same thing. Minus 4 divided by 2, negative 4 divided by 2 will give me negative 2. So this is our new equation, but that's not what it asks. It just wants the slope. So that would be B. Okay. Number 2 says, what is the slope of all lines parallel to 6x? So we're looking for parallel lines to 6x minus 2y equals 10. We're going to move our 6x over. We're solving for x, or solving for y. So we get negative 2y equals negative 6x plus 10, because 10 was positive. Now we divide everything by negative 2, and we get y is equal to 3x minus 5. 3 is our slope. We need parallel, so it must still be 3. Got to have the same slope, so that's D for number 2. All right. And number 3 says, what is the slope of all lines perpendicular to 2x minus 5y equals 40? All right. 2x minus 5y equals 40. So we're going to solve for y, and then we're going to change our slope to be perpendicular. So first, I need to subtract 2x. Remember, y stays right there. Y equals mx plus b. So y doesn't move. We move everything else away. So now I have negative 5y is equal to negative 2x plus 40. Divide everything by negative 5. And I get y is equal to, two negatives make a positive. I can't simplify 2 over 5, so 2/5 x plus 40 over negative 5 minus 8. Now, this is my slope, but I need to make it perpendicular. So I'm going to flip it, change it to 5 over 2, and then it's positive, so I'm going to make it negative. That is the slope I'm looking for, which is C. And number 4 says perpendicular to, they're just trying to make it tough on us, 3 parentheses y minus 4 is equal to negative 9x. Great. First things first, I got to distribute. So 3 times y and 3 times negative 4 gives me 3y minus 12 equals negative x. Y doesn't move. We're just moving everything else away. So add 12 to both sides, and I get 3y is equal to negative 9x plus 12. Now I divide by 3 on both sides. Everything gets divided by 3. Okay, so I get y equals negative 3x plus 4. I need to change this to be perpendicular. How do I flip 3? Well, it's 3 over 1. So now I flip that, and it becomes 1/3. This one's negative, so this one needs to stay positive. So I know that my perpendicular slope will be m equals 1/3, which is D. All right. Any questions, comments? I wish I could ask them live and in person. I miss y'all dearly. Which of the following best describes the lines x equals 2 and y equals 3? You remember x equals 2 is a Vux line. So this is number 5. X equals 2, you remember it starts with x, so it must be Vux, which is a vertical line, undefined slope. X-intercept is what it crosses. And y equals 3. You remember this Ahoy line. Horizontal line, 0 slope, y-axis. So easiest way to do it is to draw a picture. And x equals 2 at 1, 2. So we have a vertical line that goes through that point. And y equals 3 at 1, 2, 3 right here. What's the best way I could describe those lines? Well, they look perpendicular to me. So let's look at them. We know that this slope is going to be 0, 0x plus 3 is what it is. Y equals 0x plus 3. How do I take this and flip it? Well, currently it's 0 over 1. Now, if I flip that, I get 1 over 0. That's an undefined slope. 0 on the bottom is an undefined slope, which is what I have here. So these are, perpendicular. You'll learn about transversals later. They are intersecting, which is B, but that's not good enough. That's not the best description. The best description is D, perpendicular. All right. And then the rest of these, let's see. It says A, B, and C determine if they are parallel, perpendicular, or neither. So let's do all 3 of them. Let's see how quickly we can do these. A says y equals negative x plus 4, and the other one says y equals x minus 8. We don't really care about this stuff. We just need to see if these are the same slopes or opposite reciprocals. Well, what is that? This first one's a negative 1. The second one's a positive 1. So I know that they're not parallel. Are they opposite reciprocals? Well, if I make this one a whole number, negative 1 over 1, and this one a fraction, I go 1 over 1. Well, let's look at this one. What if I flip it? It becomes 1 over 1, and now I have to change the sign. Positive. Do these match up? They're positive 1 over 1. Yes, so these are perpendicular for A. To go from negative 1 to 1, you must flip it and change your sign. That is perpendicular. All right, it's just one of those special case scenarios. B says 2y plus 6x equals 7, and y equals negative 3x plus 2. We already have negative 3 here. We need to see if it's positive 1/3 for perpendicular or negative 3 for parallel. So let's solve for y. Minus 6x. 2y is equal to negative 6x plus 7. Divide by 2. And we don't really care about that part. Y is equal to negative 6 over 2, which is negative 3x. They're the same, so they are parallel. And then C says 6y minus 12x equals negative 18. And y plus, I'll write it over here. Y plus 2x equals 1. All right, solve for y over here by moving our 12x over. And I get 6y is equal to 12x minus 18. Divide everything by 6. And I get y is equal to, 2x minus 3. All right, now this one, we just move our 2x over. And we get y is equal to negative 2x plus 1. Are they opposites? Yes. Are they reciprocals? No. So these are neither. Now, pop quiz, hot shot. Are you ready for this? Are these two lines parallel? Y equals 2x minus 3 and y equals 2x minus 3. Are those two lines parallel? They have the same slope, but are they parallel? Look back at your notes. I'll give you some time to think about it. You have less than 20 seconds. And the answer is no, they are not parallel because you have to have the same slope and different y-intercepts. These must be different. All right, have a great day.